Hello everyone, this is Shaji Tannan. Welcome to my channel Crack Chemistry. Today I am going to discuss a class 11 topic. The name of the topic is Redox Reactions Part 2. In today's session, I will discuss balancing of chemical equations by oxidation number method. Before starting, I want to remind you to subscribe to my channel for getting information about further important uploads. And don't forget to like and share this video with your friends. So come with me and let's crack chemistry. So as I told you, the name of the topic is balancing of redox reactions by oxidation number method. There are two methods which are used to balance the chemical equation for redox processes. One of this method is the oxidation number method, and the second method involves the splitting of redox reactions into two half reactions. So in today's session, I will discuss the oxidation number method. Another method will be discussed in the next session. So, if you have been asked to balance a chemical equation, you are free to balance it by any of the method. It depends on your choice. But in your school exams, you may be given instructions to balance a redox reaction by a particular method. Then you have to follow that method only. So I'm going to discuss the first method, oxidation number method. So this method has following steps. Step number 1 is that write the skeletal redox equation for all the known reactants and products. So you will write a skeletal redox equation. So step 2 is you will indicate the oxidation number of all the atoms above them. Then step 3, identify atoms which undergo a change in oxidation number. So you will find two elements will be involved here. The one whose oxidation number increases, which is a reducing agent, and the other one whose oxidation number decreases, which will be the oxidizing agent. Then step 4, you have to calculate increase or decrease in oxidation number per atom. If more than one atom of the same element is involved, find out the total increase or decrease in oxidation number. Then you have to multiply this increase or decrease of oxidation number with the number of atoms which are undergoing the change. This step will become more clear to you once we will discuss few examples. Then next step, equate the increase in oxidation number with decrease in oxidation number on the reactant side by multiplying the formula of oxidizing and reducing agents by a suitable number. So in next step, you will equate the increase in oxidation number with a decrease in oxidation number in the reactant side by multiplying the formula of oxidizing and reducing agents by a suitable number. Next step is balance all other atoms except hydrogen and oxygen. Finally, you have to balance hydrogen and oxygen, and balancing of hydrogen and oxygen depends whether the medium is neutral, acidic or basic. This step will become clear to you when we will discuss few examples. So I am going to explain this method by considering few examples. So first example is copper reacts with nitric acid. A brown gas is formed and the solution turns blue. And the equation is given to you. So copper reacts with nitric acid, so Cu plus NO3 minus. NO3 minus is the nitrate ion which comes from nitric acid. So Cu plus NO3 minus gives you NO2 plus Cu2 plus. So step number first is that you have to write the skeletal equation. So skeletal equation is the unbalanced chemical equation which is written here. Cu plus NO3 minus is equal to NO2 plus Cu2 plus. What will be the step 2? The next step will be write the oxidation number of each atom above them. So oxidation number of copper is 0. So it is written here in the reactant side. Oxidation number of nitrogen in the reactant side is plus 5. Oxidation number of oxygen in the reactant side is minus 2. Oxidation number of nitrogen in product side is plus 4. Oxygen again minus 2. Copper oxidation number. Oxidation number of cupric ion in product side is plus 2. So here it is clear to you oxidation number of copper increases by 2 per atom. Changes from 0 to plus 2. And the oxidation number of nitrogen decreases from plus 5 to plus 4. So there's a decrease in 1 per atom. So you can see here oxidation number of copper changes from 0 to plus 2, which I'm showing here. Oxidation number changes from 0 to plus 2. It means copper is undergoing oxidation. Oxidation number of nitrogen decreases from plus 5 to plus 4. So oxidation number of nitrogen decreases by 1 per atom. It means oxidation number of copper increases by 2 per atom. It undergoes oxidation. So it will be a reducing agent. Now look at nitrogen. Oxidation number of nitrogen decreases from plus 5 to plus 4. So there is a decrease of 1 per atom. It means nitrogen undergoes reduction and it will act as an oxidizing agent. So in the next step, we will make this increase and decrease equal. So we can see here, oxidation number of copper increases by 2 per atom and oxidation number of nitrogen decreases by 1 per atom. So we will make this increase and decrease equal by multiplying oxidizing agent and reducing agent with a suitable number. So we can see here oxidation number of copper increases by a factor of 2 and oxidation number of nitrogen decreases by a factor of 1. We will make this increase in oxidation number and decrease in oxidation number equal by multiplying copper with the term 1 and nitrate ion with the term 2. So we will multiply nitrate ion with the term 2 and copper with the term 1. So which is shown in the next slide. You can see here copper we have multiplied with 1 and nitrate ion we are multiplying with 2. Then the next step is that balance all other atoms except hydrogen and oxygen. Copper is already balanced, but in the reactant side we have 2 nitrogen and product side we have only 1 nitrogen. The next step we will balance nitrogen in the product side by multiplying NO2 with 2. So which is done here. In the next step you have to balance hydrogen and oxygen. As I told you in the beginning, balancing of hydrogen and oxygen depends on the medium. So as in this reaction nitric acid is present, a reaction is taking place in acidic medium. So let's see how we can balance hydrogen and oxygen. So for balancing oxygen atom, we will add water molecules to the side which is deficient in oxygen. So we can see here that this side is having 6 oxygen atoms and this side is having, product side is having 4 oxygen atoms. So we can see that product side is having 2 oxygen atoms less. So in the product side we will add 2 H2O which we have added here. So now oxygen is also balanced. Only unbalanced element is hydrogen. We will balance hydrogen by adding required number of H plus ion to the side which is deficient in hydrogen. So we will add 4 H plus in the reactant side. So we can see that our reaction is balanced here. Now one more important point I want to tell you, that if you are balancing the reaction correctly, make sure that the charge in reactant and product side is equal. So we can count the charge like this. You can see here copper is neutral, having no charge, but here the nitrate ion is having 1 negative charge. But as we have 2 nitrate ions, so charge will be 2 negative. And here 4 proton means 4 positive charge. So total we will have 2 positive charges in the reactant side. Now look at the product side. Product side we have Cu2 plus, which is having 2 positive charges. So we can see that charges on both reactant and product side are equal and we have balanced our reaction. Now the next example is Fe2O3 plus C is equal to Fe plus CO. So we can go a little bit fast this time. Step first is that you have to write the skeletal equation. And in this skeletal equation we have written oxidation number of atoms above them. Oxidation number of iron in Fe2O3 is plus 3. Oxidation number of oxygen is minus 2. Oxidation number of carbon is 0. Oxidation number of iron is also 0 because you know that oxidation number of free elements is always taken as 0. Oxidation number of carbon in CO is plus 2. Oxygen is again minus 2. So if you look carefully, you can find that the oxidation number of iron decreases by 3 per atoms. Oxidation number of iron changes from plus 3 to 0. It means it decreases by 3 per atom. But we have 2 iron atoms. So total decrease will be 2 into 3, 6 per atom. So total decrease will be 6. Similarly, oxidation number of carbon increases from 0 to +2. So it increases by 2 per atom, which I am going to explain in the next step. So you can see here oxidation number of iron decreases by 3 per atom. But as we have 2 atoms, so that will be 3 into 2 per 2 atoms. So the decrease will be of 6. Total decrease will be of 6 for 2 atoms. And in the case of carbon, oxidation number increases by 2. So we can see here there are 2 terms involved, 2 numbers involved. For carbon, the increase is 2. And for iron, the decrease is 6 for 2 per atoms. We will simplify these numbers as 1 and 3. So what we will do in the next step, we will make the increase in oxidation number and decrease in oxidation number equal by multiplying them with a suitable term. So we will multiply carbon by the term 3 and Fe2O3 by the term 1. So this is shown in the next step. We have multiplied carbon with the term 3. Now, in the next step, what we have to do, we have to balance all other atoms except hydrogen and oxygen. So we can see carbon is 3 and iron is 2. So we will balance them in the product side in the next step. So we have written 2 iron here and 3 CO. So as the reaction is taking place in neutral medium, we can see that the charge is already balanced and the number of atoms are equal in both reactant and product side. I hope it is clear to you. Now I am going to take one more example. Fe2 plus Cr2O7 minus plus H plus gives you Fe3 plus Cr3 plus H2O. The reaction is taking place in acidic medium. So first step will be the same. We will write the skeletal equation along with the oxidation number of each atom will be written above them. So Fe2 plus. We will write the skeletal equation and in this skeletal equation oxidation number of each atom will be written above them. So Fe2 plus, its oxidation number is +2. See, oxidation number of chromium in Cr2O7 minus is +6. Oxidation number of oxygen is -2. And here we have H plus whose oxidation number is +1. Oxidation number of ferric ion is +3. Oxidation number of Cr3 plus ion is +3 and oxidation number of hydrogen in water is +1 and oxygen is -2. So next step we will find out the elements whose oxidation number increases or decreases. So it is clear to you, you can see that oxidation number of iron increases from +2 to +3. It means it is undergoing oxidation. It will be a reducing agent. And its oxidation number increases 1 per atom. Now look at the chromium atom. In case of chromium, you can see the oxidation number decreases from +6 to +3. Means there is a decrease of 3 per atom. But you can see here we have 2 chromium atoms. So decrease will be 2 into 3 per 2 chromium atoms. This I am going to explain in the next step. You can see here for iron oxidation number increases by 1 per atom. And for chromium, for 1 chromium atom oxidation number decreases by 3 per atom. But as we have 2 chromium atoms, so oxidation number will decrease by 3 into 2 is equal to 6 for 2 chromium atoms. So I am writing these numbers here. Oxidation number of iron increases by 1. And oxidation number of chromium decreases by 6 per 2 chromium atoms. So in the next step, we have to make this increase and decrease equal by multiplying the oxidizing agent and reducing agents with a suitable number. So what we will do, we will multiply Cr2O7 2 minus by the term 1 and Fe2 plus by the term 6. So which is shown here. We have written here 6 Fe2 plus Cr2O7 2 minus plus H plus. Now we have to balance all other atoms except hydrogen and oxygen. So we can see that in the reactant side we have 6Fe2 plus, so product we have to write 6Fe3 plus. In the reactant side we have Cr2O7 minus, means chromium, 2 chromium atoms are there. We have to write here 2 Cr3 plus. So this is shown here, 6Fe2 plus Cr2O7 minus. We are writing 6 here, 6Fe3 plus, and Cr3 plus we are multiplying by 2. Now all other atoms except hydrogen and oxygen have been balanced. Now we have to balance hydrogen and oxygen. As the reaction is taking place in acidic medium, what we have to do? We have to balance first oxygen by adding water molecule to the side which is deficient in oxygen. So we can see here in the reactant side we have 7 oxygen atoms, but in the product side we have only 1. So we have to write 7H2O in the product side. So this is shown here. Here in the product side we have written 7H2O. So now the oxygen atoms are also balanced, and finally we have to balance hydrogen. As the reaction is taking place in acidic medium, we have to balance hydrogen by adding required number of H plus. So we can see here in the product side we have 14 hydrogen. So in the reactant side we will write 14 H plus, which I am going to show you in the next step. So we can see here this is the final balance equation, 6Fe2 plus Cr2O7 minus plus 14H plus gives you 6Fe3 plus 2Cr3 plus 7H2O. And as I told you, as a final check, you must check the charge must be same on both the side, reactant and product side. So quickly I am going to check the charge here. Iron total charge on ferrous iron will be 12, because one ferrous iron is having 2 positive charge, so 6 will have 12 positive charge, but charge on Cr2O7 minus is 2 negative, so that will be 10 negative charge, and 10 plus 14 positive charge means in the reactant side we have 24 positive charge, 24 units of positive charge. Now look at the product side. Product side we have ferric iron is having 3 positive charges, so 6 will have 18 positive charge, and here chromic iron is having 3 positive charge, so 3 into 2 6, so we will have 18 plus 6 is the 24 units of positive charge in the product side also. So charge is equal in both reactant and product side, so our reaction has been balanced correctly. Now the next question, permanganate ion react with bromide ion in basic medium to give manganese dioxide and bromate ions. Write the balanced chemical equation for the reaction. Student, this is your NCERT problem. So first thing is that we have to write the skeletal equation. In this question, the skeletal equation has not been given to you. So you have to write the skeletal equation first. Permanganate ion is MnO4 minus, bromide ion is Br minus, manganese dioxide is MnO2 and bromate ion is BrO3 minus. Second step, we will write the oxidation number of each atom above them. So oxidation number of manganese is +7, we have written here. Oxidation number of oxygen -2, bromide ion -1. Oxidation number of manganese in MnO2 is +4, oxygen again -2. Oxidation number of bromine in BrO3 minus is +5, and oxidation number of oxygen in BrO3 minus is -2. So now we will find out the atoms whose oxidation number increases and decreases. So oxidation number of manganese decreases from +7 to +4. So we can see that oxidation number decreases by 3 per atom. So it means MnO4 minus undergoes reduction. It will be an oxidizing agent. Similarly, oxidation number of bromine increases from -1 to +5. It means oxidation number of bromine increases by a factor of 6. So Br minus undergoes oxidation, hence it is a reducing agent. This I am going to show you in the next step. So oxidation number of manganese decreases by 3 per atom. And oxidation number of bromine increases by 6 per atom. So I am writing the numbers here. This is for manganese, decrease of 3 per atom, and for bromine the increase is 6 per atom. So we will further simplify these number as 1 into 2. So now in the next step we have to make increase in oxidation number equal to decrease in oxidation number by multiplying MnO4 minus by 2 and Br minus by 3. So we have to make this increase and decrease equal by multiplying Br minus by the term 1 and MnO4 minus by the term 2, which has been shown in the next slide. You can see here MnO4 minus we have multiplied by 2 and Br minus by 1. Now the next step is that you have to balance all other atoms except hydrogen and oxygen. We can see that in the reactant side we have 2 manganese. So in the product side we will multiply MnO2 by the term 2 and bromine is already balanced. So this step you can see here 2Mn and 2MnO2. Now we have to balance hydrogen and oxygen. But don't forget that the reaction is taking place in basic medium. You can balance oxygen by adding OH minus to the side which is deficient in oxygen. So we can see here in the reactant side we have 4 oxygen atoms. But in the product side we have 3 oxygen atoms. So we can see that the product side is deficient in oxygen and it is having 1 oxygen less. So what we will do, we will add OH minus to the product side. So we have added OH minus to the product side. So oxygen is also balanced. You can see, you can check in reactant and product side we have 4 oxygen. Now only unbalanced atom is the hydrogen. So for balancing hydrogen atom, what we have to see, we have to add 1 water molecule. Please listen carefully. We have to add 1 water molecule for each hydrogen atom to the side which is deficient in hydrogen. So you can see here, if the reaction is taking place in basic medium, you can balance hydrogen by a very simple trick I am going to tell you. For each hydrogen atom, you have to add 1 water molecule to the side which is deficient in hydrogen. So you can see here, in the product side we have 1 hydrogen, but in the reactant side we have none. So in the reactant side we will add 1 water molecule for 1 hydrogen atom. And at the same time we will add 1 OH minus to the opposite side. So we have added H2O here. At the same time we have added OH minus. So you can check your final equation is 2MnO4 minus plus Br minus plus H2O is equal to 2MnO2 plus BrO3 minus plus 2OH minus. Now again you can cross check the equation by checking the charges. In the reactant side we have 2 negative charges here, 1 negative charge here. Total of 3 negative charges we have in the reactant side. In the product side you have 1 negative charge here, 2 negative charge here. The total of 3 negative charges we have in the product side. So students, I hope you enjoyed this video, you understood each and every point. Thank you so much for watching this video and don't forget to watch my next video. Don't forget to subscribe my channel and please like and share this video with your friends. Thank you so much. Have a nice day.